Hello, we are Team Aeroplover from Temasek Polytechnic. This is our animation simulation. We decided to have the satellite at an inclination angle of 0 degrees. 16 satellites will also be orbiting at a speed of 7.23 kilometers per second. The paradigm that we will be using is the constellation arrangement. However, not all satellites will be activated. Out of 16 satellites, 2 satellites will be used as pairs. The satellites will be orbiting at a distance of 350 kilometers from Earth. This is our single satellite design, which will make up with our constellation. The core components of our satellites are, in red, the antenna, purple, a radio transmitter for uplinking commands, yellow, power system, most often solar cells plus a battery or power bus. Last but not least, our two main sensors to collect our readings are in silver, the reflected ray sensor, and in brown, the soil moisture sensor. These components and sensors complement one another to help us overcome our problems on deforestation. Deforestation poses a serious impact to countries around the world due to its various economic, environmental, and health impact. Hence, to solve this problem, we first got to tackle the root of it. Moving on, our team have decided on utilizing albedo sensor for the design satellite. It is a type of passive sensor that detects the amount of reflected near-infrared radiation from the green vegetation that are being examined. As can be seen, the electromagnetic radiation emitted by the sun to the green vegetation is absorbed as well as reflected by the chlorophyll. Furthermore, the internal structure of green leaves acts as an excellent reflector of near-infrared radiation. This reflected near-infrared radiation has a unique spectral reflectance signatures that is detected and identified by the sensor. For soil moisture sensors, the sensors detects the microwave radiations emitted from the soil. Wet soil emits less microwaves than dry soil. Vegetation also emits microwave radiation, but can be avoided by using frequency of around 1 GHz. There will be 16 satellites orbiting around the Earth. They are constellation satellites whereby they will overlap the scanning area to increase the accuracy of the result. The satellite will then send the data back to Earth and be analyzed by the in charge to see which area have been affected. The process repeat again and again. Satellites do not last forever. Since our satellites are positioned at a LEO orbit, we are planning to send it back to Earth once it reaches its lifetime. As the satellite travels back to Earth, it converts kinetic energy into thermal energy. Just like a bullet, when the satellite travels downwards at a high velocity, the satellite will experience a large impact. The thermal energy will also contribute, hence destroying the satellite as it reaches Earth. We have come to the end of the simulation. If this mission is a success, what will the next launch be?